So for section 11.8, we're going to be solving quadratic and rational inequalities. We're not graphing these, or not doing like a, when I say that, we're not putting them on an XY axis. We will be putting these on a number line. And so the solving isn't the hard part. We're going to find kind of like the x-intercepts. We're going to be solving these for x using our methods. So either, first of all, I'm going to check if there's any factoring. More often than not, these will do that. Second, worst case scenario, I could complete the square. Generally, I wouldn't do that unless the a was positive and the b was even. Or last resort, we could use the quadratic formula. So we're going to solve just like we have before, formula, but the difference is instead of x being equal to at the end, we're going to end up with an inequality x is greater than, or less than, and then we'll have x is greater than and less. So one of these is going to be an or, the other one's going to be an and. We don't need to make a big deal out of it. We can solve these and we'll kind of talk through it as we go. But we're going to solve these just like we did before. Here's what I mean. If this was equal to 0, we would have no problem solving this. We'd go, well, we could solve that by, what's the F word? Factor this sucker. See, what's going to happen is, we have x times x. What multiplies to make the 12 combines to make a 1. How about a 4 and a 3? And to be a negative 1, the 4 would need to be negative, the 3 would need to be positive. So what we do is we find our roots first. We find our zeros first. Our zeros, by setting each of these equal to 0, are at 4, and are at negative 3. So I could put a point at 1, 2, 3, 4, and a point at negative 3. These are kind of my key regions. These are my zeros. That's what will make the equation equal 0. The question is, where is it greater than 0? So after we kind of find the zeros, or the roots, or the key points, then what we do is we check the regions around the points. So I see 3 regions. I see one to the left, one to the right, and one in the middle. Okay? So I'm going to check a couple values with this. I'm going to check to the left of negative 3. So how about negative 4? I'm going to check in the middle. And I'm going to check to the right of 4. How about 5? Plugging in a negative 4. Negative 4 squared is 16. Minus negative 4 is plus 4. Minus 12. That gives me 20 minus 12. 8 is greater than 0. Negative 4 is one of our solutions. What does that mean? We will shade to the left of that key point. How do we know? Well, because if negative 4 is greater than negative 5, it will also be greater. Negative 6 will be greater. Anything to the left of this will be greater. Okay? When we check 0, because we know that the negative 3 gives us a 0, we know that the 4 gives us a 0, so we're going to check something in the middle, which is 0. Well, I get 0 minus 0 minus 12. I get negative 12 is greater than 0. That is not true. So we will not shade in the middle. We don't shade that region. And then when I check a number greater than the 4 to the right there, we check a 5. That's 25 minus 5 minus 12. How about 8 is greater than 0, which is once again true, so we would shade that direction. Last thing, and we've done this before, what symbols will we use? Well, because it was a not equal to, instead of a bracket, we use parentheses. So technically, now that I have this graph, we could write the solution a couple ways. We could write this as x is less than 3, or x is greater than 4. And we could write our answer as an interval from negative infinity to 3, or 4 to infinity. Okay? None of this is new, but basically I'd be looking for all 3 of these solutions. What if we had done less than 0? Same answer, same key points. So we're going to have the same -3 and the 4. Well, I would be checking the same 3 points, wouldn't I? I'd still be checking -4. Sorry, let me clean that up. I'd be checking 0, and I'd be checking 5. Well, this time it'd be less than 0, so the first one would give me 8 is less than 0, which is not true, so I wouldn't shade to the left of 3. The second one would give me -12 is less than 0, which is true, so I would shade the middle section. And if I checked a 5, I would get that 8 is less than 0 again, which is not true. So this tells me this answer, instead of being an or, it would be what? X is greater than -3, and X is less than 4. We keep just the middle, the overlap, with the parentheses. And our interval, I would just put from -3 to +4, because we can write those together as an and. If you want to write that as two separate statements, you can. You could put -3 to infinity and -infinity to 4. As long as the and is there, those two say the same things. But this kind of is going to lead us to an overall, I don't want to overgeneralize this, but for you guys, if it is a greater than, it will shade outward. If the A was negative, this whole thing would change, but for now, just if it's a greater than, it will shade outward. It will tend to be an or. If it's less than 0, it will tend to shade inward. It will tend to be an and. Okay? The only exception to that is if the A is negative, and we're not going to be really messing with that. But if you're not sure, then you can always check the points, check the regions, and that's really the method I want you to focus on the most. Check the regions around the roots. What about this one? How are you going to solve this one? So he's like, I don't know, it's complicated. Quadratic formula. It's not a bad choice. See, the A is not a 1, the B is not even. I'm not going to complete the square. But if this factors, that would make my life a lot easier. So yes, you can run this through the quadratic formula, but let's check the AC here. 3 times -10, our B. Are there two things that multiply to make 30, combine to make 13? It could be a 3 and a 10, which won't work, because to make the -13, they have to both be negative, so that won't work. Like, see, I told you it didn't factor. Wait a sec, it could be a 2 and a 15. Where the 15 was negative and the 2 was. So this actually will factor. If you take the time to check it, this could factor. What do we say? Plus 2m minus 15m. First two have only an m in common. Second two have a minus 5 in common. So that now I can factor out 3m plus 2, and I'm left with m minus 5. I need my critical points, setting each of these equal to 0. Minus 2, minus 2. 3m equals -2, or -2 thirds. M minus 5, so that m equals 5. So those are my 2 points. I'm going to, when I graph this, sketch it from -2 thirds up to 1, 2, 3, 4, 5. Is this one going to shade towards the middle or toward the outside? If you're not sure, check a region. Check 0. Going back to the original equation, if I plug in a 0, too far, if I plug in a 0, I get 0, 0, -10, less than or equal to 0. That is true. So that tells me I'm shading in the middle of these suckers. Just to be safe, I could check something to the left of -2 thirds, like, I don't know, -1. That would give me 3 plus 13 minus 10 less than 0. That would give me that 6 is less than or equal to 0. That didn't work. I could check 6. That would be kind of big and sucky, but that'll work. How about 36 times 3 would be 108 minus 78 minus 10. 108 minus 88 is 20 less than 0. No. So it's only shaded in the middle. Since the original inequality was equal to, I'm going to use a bracket this time. So this was an and. So what is our answer really? Well, m was greater than or equal to negative 2/3, and m was less than or equal to 5. And our interval, I would just put from negative 2/3 to 5. All three answers. This, I think, is the most complicated thing. The next part is actually, I think, a little easier, the rational, but go ahead and work through these. They're not making these too crazy. We'll have some at the end. Some of them are to be factored. These shouldn't be too hard to get the points for these. What if it's a rational equation? Well, we clear the fraction just like we have in the past. So I'm going to multiply both sides by the denominator, x minus 3. Clears it on the left side, leaving us with negative 1 is less than x minus 3. Solving. 2 is less than x, or x is greater than 2. We can graph this, starting at 2. Greater is to the right, with a parenthesis. One issue, though. See, with our original equation, there's a restriction whenever I have a rational equation. The denominator cannot equal 0, which means x minus 3 cannot equal 0, which means that x cannot equal 3. And here we just shaded in 3. So what do we have to do? We basically have to put a hole in the graph. We have to sit there and say this cannot equal 3. What we do is you could put an open dot, or what I would do since we're using the parentheses is that 3, I'd put a parenthesis to the left and to the right. Basically there's a hole in the graph. Even though we solved this, x cannot equal 3, so there's a hole in the graph right there. So we end up with two inequalities from 2 to 3, and then from 3 on to infinity. So that 3 now has a hole because of the denominator, because of that x minus 3 being in the denominator. Next one, where's the hole? Well, what's the denominator? X minus 1 cannot be 0, so x cannot be 1. Keep that in mind. When we go to graph it, if we shade a 1, we have to put a hole there. How do we solve this? We've done these before. That's not super complicated. Multiply both sides by the denominator, and we get x plus 2 less than or equal to 5x minus 5. Isolating the x, adding the 5, we get 7 less than or equal to 4x, so that 7/4 less than or equal to x, or x is greater than or equal to 7/4. When I go to graph this, well, where is 7/4? Well, between 1 and 2 would be 7/4, 1.75. And we said x is greater than or equal to that. So greater than means to the right. Equal to means a bracket. This is not new. Where was our hole? Well, it was over here at 1. But we didn't shade the 1. so that's not an issue this time. This is our answer, just from 7/4 on to infinity. Why? Don't forget a bracket on the 7/4. Why? Because the whole didn't fall in the region that we shaded. So there is a restriction on x, but it didn't make a difference this time. Last but not least, where's the whole? Denominator cannot be 0. X cannot be 2. Keep that in mind. Multiply by the denominator. X plus 1 greater than about 2x minus 4. Solving this, isolate the x, add the 4, so that 5 is greater than x, or x is less than 5. Less than 5. 1, 2, 3, 4, 5. Less than is to the left. Not equal to, we put a parenthesis. Is there a hole this time? There was a hole at 2, and we shaded 2. So we have to put the hole on 2. What does that do? It creates two regions now, from negative infinity to 2, or 2 to 5. All this did was create a hole on the 2. Not a big deal, not anything terribly new. Like I said, this isn't too hard of a section to finish up at the end. So finish this up, and we should be ready for the test.